In this lesson, we are going to review all the rules of factoring you learned for 2 months in intermediate algebra. So we're going to cover them all in one day. Hopefully, if you had me in intermediate algebra, I drilled you in factoring and we did it forever and ever and ever. So hopefully it'll come back to you, but I'm not expecting you to remember everything from factoring. So if you are having a hard time after this lesson, please come see me, because this is a skill you will need the whole rest of the year. There's a reason when I had you in Algebra 1 I freaked out about this skill, because we need to know it inside and out. So today we're going to review it. I'm going to reteach all of it, and then if it's not coming back to you after this lesson where you do some problems on your own, I have extra work you could do on it just to make sure you get the hang of it and kind of relearn it. But please don't be afraid to come ask for that, because we really need to understand this, and I really want to help you understand it, so it's going to make it easier for the rest of the year. So here's a quick reminder of factoring that I have on the top of your notes. The first thing says always take out the GCF first. That's our golden rule of factoring. When you see a problem, you look and say, is there a greatest common factor I can factor out? So we will ask that for every problem we do today. Then you look if it has 2 terms, 3 terms, or 4 terms. And we'll talk about that as we do them today. 2 terms is the difference of squares, which we'll do. 3 terms is just what we called kind of normal factoring, where you undo the FOIL. So you're undoing the FOILing that was done. And 4 terms is factor by grouping. So if I am given lots of factoring problems, sometimes what I could do if it seems overwhelming, like let's say today when I give you some practice problems, if you're overwhelmed by what to do first, I would go through and take out the GCF in all of them first. And then I'd go and say, okay, which ones have 2 terms? Let me do those because they're all kind of the same. Then I'd go to the 3 terms, and then I'd go to the 4 terms, because they all have specific rules that follow those. So if you're feeling overwhelmed by the amount of problems you would get, that's an option you could always do to kind of get the hang of it again. So let's just dive right in. Number 1, the first thing I ask myself is there a greatest common factor in this problem? Meaning, my numbers, my coefficients here are a 1, a 7, and a 12. Can they all be divided by the same number? And they can't, right? Anytime you have a 1, you're out of luck. So I do not have a greatest common factor for this problem. So from here then what I do is I make my 2 parentheses, and then I'm looking for my factors of x squared. The only choices I have for x squared are x and x. Then I look at my factors of 12. Now if you remember, you want your factors of 12 to somehow add to make this 7. So I'm going to look for factors of 12 that I could find a combination to make a 7 out of. Hopefully this will come back to you as you start to work on it, because this is one you would have done in your head really quick when you got at the end of factoring. But if not, this is the work you would do. So I'm going to look at this and say, okay, this adds up to 13, 8, and 7. Here's my one I want. 3 and 4. So I'm going to put in a plus 3 and a plus 4. I'm using both positives because my 12 is positive and my 7 is positive. So then just to double check that this is correct, I would FOIL this out. So I'd have x squared plus 4x plus 3x plus 12. That does make a 7x. I get my original problem. So there's my factors. You don't have to actually show me this step. So a lot of you will do this in your head and kind of use your fingers to do it. That's totally fine. I also don't need to see this. Some of you right now can just write this answer. Some of you will take a while to get remembered of how to do this. But whenever you get to that point, no work is needed for these. Number 2 then. Same thing, I look at that and say, is there a greatest common factor? There's not, right, because I have a 1 in that first term. So then I say, okay, it's 3 terms. And 3 terms really means 1, 2, 3 things being added or subtracted. So this is a trinomial, which is 3 terms. So now I'm going to make my 2 parentheses, and I'm going to do the same thing as the last problem. What are my factors of x squared? Hopefully you say that's x and x. And then I'm looking for factors of negative 15 when combined to make a 2. So now I have a negative, so I'm going to have a plus and a minus, if you remember that, because positive and a negative multiply to make a negative. So I have factors of 15 are 1 and 15, 3 and 5. So I need to somehow make a 2 out of these. So when you look at the 1 and 15, you're going to say, well, that could make a 16 or a 14. If I add them, it's 16. If I subtract them, it's 14. The 3 and 5 could make an 8 or a 2. If I add them, it's 8. If I subtract them, it's 2. Well, I'm looking for a 2, right? So I know that I could take, to get that 2, I'd take 5 minus 3. So I need a positive 5 and a negative 3. Now I think this is right, but I still want to check it. So I'm going to FOIL that out. X squared minus 3x plus 5x minus 15. Does that add up to 2x? It does. So there's my answer. Number 3, is there a greatest common factor? No, 7 and 13 are primes. There's no greatest common factor. So now, this is the first one where when I write my two parentheses, what are my factors of 2x squared? Well, it would have to be a 2x and a 1x. No other choices. So those I can plug in. Then I have factors of negative 7. So I'm either going to have 1 and negative 7 or negative 1 and positive 7. I'm not really sure which one to put in first. So I'm going to go ahead and just, let's pick the top one. So I'm going to plug in plus 1 minus 7. Now if you remember doing this, we had to plug these in and try lots of different values when we first learned it, and then you just, something kind of clicks and you get the hang of doing it in your head a little bit, and it's not as much. So if you aren't clicking right now, that's normal because you haven't done this in a while. So remember that that's going to take you a little while to get the hang of it again, and you might have to try several numbers to make it work. So right now, I would go ahead and FOIL this to see if I pick the right ones. And when I add up here, I do get negative 13x. So did I pick the right ones right away? I did, right? I got lucky. Eventually, that won't be luck that happens. It'll be my thinking skills that are working. But right now, I just chose the top one, and that worked. Had that not worked, I would have flipped the 1 and negative 7 around, meaning I would have tried this, like that. So I flipped spots here. Then if that doesn't work, you can cross this one out and go to the next one. Hopefully you remember doing that. Number 4, do I have a greatest common factor? I don't, because I have a 7, 7's prime. So again, I have a trinomial, 3 terms, so I'm going to make my two parentheses. And I'm going to look at factors of 6. This is different because I actually have some choices here for this one. I could try 1 and 6 or 2 and 3. Then I also have to look at factors of negative 20. So 1 and 20, 2 and 10, 4 and 5. And one of them has to be negative because it's a negative 20. So as I try these, if you remember doing this before, we'd have to kind of try to guess right the first time. And what I would always say is, if this middle term that you're trying to reach, oh, that's not what I wanted to do. Let's try that again and get our problem back. There we go. If this middle term that I'm trying to reach is a smaller number, my factors will be closer together. Doesn't always work, but it's good 75-80% of the time, so that's where I'm going to put my odds. So when I'm looking here at 1 and 6 or 2 and 3, I'm going to pick the two numbers that are closer together. That's what I'm going to try first. And then when I come over to my factors of 20, I would try 4 and 5 first, then I'd try 2 and 10 second, and then last I'd try 1 and 20, because they're very spread out, so they would give me a bigger middle term. So as I try these, I'm going to go 2x and 3x. Now, this is not guaranteed to work. I'm just trying this. So then I said I'd try 4 and 5 first. So I'm just going to go 5 and 4. How about? We'll go, or 4 and 5, keep it the same. So I'll go negative 4, positive 5. How about? We'll just try that because one of these has to be negative. So when I FOIL this out, I get 6x squared plus 10x minus 12x minus 20. That does not add up to 7. So this did not work. So now, before I eliminate 4 and 5, I have to actually switch their spots. So I'm going to flip them around and say 4 goes here, 5 goes here. So when I distribute, I'd have 6x squared plus 8x minus 15x minus 20. When I add those x's, I get negative 7x. Now, I needed 7x, right? And I got negative 7x. So what do I need to do to make that be a positive 7x? Hopefully you remember that you have to switch those signs. So if this was a positive 5 and this was a negative 4, look what happens when I FOIL that out. I get 6x squared minus 8x plus 15x minus 20. So now I get a positive 7x. So I don't have to change everything. I just have to change the signs if I get the same coefficient, but my sign is off. So this now would be my answer. Had that not worked, I would have crossed out 4 and 5 and started working on 2 and 10. And then remember, 2 and 3 was my guess. It could have been 1 and 6. So if all 3 of these didn't work, I would do the whole process again with 1 and 6. Number 5 then, do I have a GCF? I don't, because that's a 1 there. But I do notice that this is different than my last one because this is 2 terms. 2 terms is the difference of squares. One of the ways we explain it to you in Algebra 1 is if you want to make it 3 terms, you could just put in that, we're missing the x term, so I could put in a 0x in that spot and factor it the same way you always have. If you think of it that way, you'd go with your 2 parentheses and you'd say, okay, x and x go here. And you're looking for factors of negative 64 when added together makes 0. Well, they'd have to be the same number, right, and be opposites. And the only thing that's the same number for 64 is 8 and 8. So you'd have to have a plus 8 and a minus 8. The reason we call this the difference of squares is because both of these numbers here are perfect squares. If they're not, we can't factor them. Now, assuming you took out the greatest common factor, of course, right, because that's always what we do first. So we don't have a way to factor 2 terms if they're not both perfect squares. So what happens is you take, this is my answer here, but if you want to skip this step right here, and you can do it either way. You take the square root of both of these numbers, so x plus, and then you do 8, and x minus 8. And you always use different signs, because that middle term needs to add up to 0. Later on, we're going to do something called conjugates. You've done that, some of you have done that in Algebra 1. But when you multiply by a conjugate, you know your middle terms always cancel. And these are considered conjugates, these 2 factors here. X plus 8 and x minus 8, they look the exact same, except one's positive, one's negative. That's what a conjugate is, and we'll do a lot of work with those later. Not something you have to know now, just something I'm throwing out there for later. So there's my answer. X plus 8, x minus 8. And you could FOIL that out, and you'd see that your middle terms do indeed cancel to get 0x. So you're left with x squared minus 64. The nice thing about all of these is you can check them all by foiling. Number 6 then, do I have a greatest common factor? I do. It's a 2. So now what happens is you're going to divide both of these terms by 2. So when I divide them by 2, I factor it out. So I write it as 2. I'm undoing the distributing. That's what I'm doing there. So if I could distribute that 2 back in, I should get the original problem. Then I look at what's left in the parentheses. Is that something I can factor? And sometimes it is and sometimes it's not. So you don't have to always be able to factor this, but you always have to look to see if you can. It's 2 terms, so I'm thinking difference of 2 squares. So are they both perfect squares? They are, right? So if I was thinking to factor x squared minus 16, I would do x plus 4, so that's the square root of 16, x minus 4. Now, this 2 here, I like to call it your sibling, your annoying sibling that never leaves you alone with your friends. It's not going to go away. It doesn't just drop off. So that 2 has to hang out with you the whole time. It's like when your parents make you take your siblings to the mall with you and your friends, or a movie. It doesn't leave your side. So it's sitting on the outside, but it's always there. So that's going to be part of my solution. Alright, number 7. Do I have a greatest common factor? I'm going to say yes, right? These all can divide by what number? 2. So I would have 2, and then I'm going to divide each term by 2. 2 divided by 2 is 1x squared. 10 divided by 2 is 5. 48 divided by 2 is 24. So now I look at what's left in my parentheses. It's a trinomial, so I'm going to have 2 sets of parentheses. And then I'm going to take that annoying 2 and keep it on the outside, right? So I look at the first term. What are factors of x squared? Well, x and x are my only choices. And then I'm looking for factors of negative 24 that would make a negative 5. So I'm going to list my factors of 24. And I need one of them to be negative. Which one of these could get me a 5 somehow? So as I'm looking at these, I'm looking at that first one, I'm going, okay, 25 or 23. I add them and subtract them, see what I get. Not going to work. 14 and 10 for 12 and 2. No. 11 and 5. 5. Yes, 5 is what I need. If I took 8 minus 3, I would get a 5. But I actually want what? I want negative 5. So if I had negative 8 plus 3, I'd get negative 5. So that's how I write them. Negative 8 plus 3. Now just to check my work, I'm going to distribute this. So x squared plus 3x minus 8x minus 24. That does add up to a negative 5x. So that works. Number 8. This is the first one we have that has 4 terms. So I still can ask myself, is there a greatest common factor? And there's not, because I have a 1x there. But this has 4 different things being added and subtracted. You will notice it wasn't given to you in descending order. And for our purposes, we are going to give you the problems in a way that you can factor them from the start. So don't change the order that you're given the problems, because it could mess you up. They can give them to you out of order sometimes. We just choose not to because we don't do a lot of factor by grouping. So what you do with the first thing for factor by grouping is you underline the first 2 terms and you underline the last 2. Then you look at the first 2 and you say, what's the greatest common factor between those 2 numbers? So between x and 3, what's the greatest common factor? There isn't one, right? There is always a 1 though. Everything can be divided by 1, and you have to take out a greatest common factor in factor by grouping. So I'm going to say I can divide these by 1 and just get the same thing. But having this 1 on the outside is important. Then in my second group of terms, I look and say, what's my greatest common factor? If you remember, x being in both terms is a greatest common factor, and you always take the smallest one. So x squared is my greatest common factor there. And then when I divide both of these by x squared, I would get x plus 3. Now what I want you to notice right now is right here. Our parentheses have the exact same value. That's important. In factor by grouping, that should happen, or I can't factor it, or I made a mistake. So now what I do is I take these outside numbers, and that becomes one of the factors in my answer. Then these 2 that happen to be the same, I take that as my other factor. Some students want to take that twice and put like a squared here, but I actually didn't take x plus 3 twice. I took it out of the first half of the problem, and I took it out of the second half of the problem. So I really only took it out once. This is actually my answer, which is kind of hard to believe. So just to double check it with myself, I could FOIL this and make sure I did it right. So I'd have x plus 3 plus x cubed plus 3x squared. And I do get back to the original problem, so it does check. Hopefully that jogged your memory of factor by grouping. If not, we can always go through that tomorrow too. The last one we're going to do together is number 9. This one, do I have a greatest common factor? Well, number-wise, I see that I could divide by a 5, right? So all these can be divided by 5. And then I look at the variables and I see that I have an x in every term. I will take the lowest degree of my x. So x to the first is the one I can take out. So I'm going to divide everything by 5x. So I'd have 2x squared plus 3x plus 35. And there wouldn't be an x and an x, those x's are gone. From here then, I look inside my parentheses and I see that I have a trinomial. So I'm going to factor using 2 parentheses. So I keep that 5x on the outside, and I say, okay, what are factors of 2x squared? Well, that'd be 2x and 1x, right? And then I'm looking for factors of 35. So 1 and 35, or 5 and 7. To make a 3, I think I'm going to have to use 5 and 7. Now you'll notice, when I add 5 and 7 I get 12, and when I subtract them I get 2. Neither of those make a 3, do they? But remember, I have a 2 here that's going to be multiplied by something. So that changes it. You can't just assume they're going to work out that way when there's a 2 there. So I'm just going to go ahead and try. I don't think the 1 and 35 is going to work. So I'm going to go ahead and try and plug in 5 and 7. And I'll just put them exactly as they listed. 5 and 7. When I FOIL this, I get 2x squared plus 14x plus 5x plus 35. That would give me 19x, and I need a 3x, right? That's not going to work. So let's flip that 5 and 7 around. So we'll put the 7 here, we'll put the 5 here. So I'd have 2x squared plus 10x plus 7x plus 35. That makes 17. If I could subtract them, it would make it 3, wouldn't it? But I don't have a negative in here, so I can't do that. Doesn't work, right? It looks like it wants to, but doesn't. So now I should try 1 and 35. Some of you right now are thinking, I know that's not going to work, right? You can kind of see that, but let's try it. Because we got to just double check here. I'm thinking, I don't know what's going on with this problem, right? So let's go 1 and 35. 2x squared plus 70x plus 1x. I can already see that's not going to add up to 3, right? If I flip the 1 and 35 around, I'd have 2x squared plus 2x plus 35x. Still not going to add up to 3. I've tried every option I have. The problem is I don't have a negative here, and somehow these numbers can't add up to a 3 because they're bigger than 3. So when you've done that, this is as far as you can go. No one said it had to keep being factored. You have to try it, and if you can't factor it, you're done. You have done something though. You took out this 5x. You took out the GCF. So that is a change in the problem. It's just that you can't keep going after that. So this is a good answer right here. I would like you guys to do the back problems for tomorrow. So 10 through 18 is what you're going to try right now on your own. And then tomorrow we'll go through those answers and see which ones you have questions on.